GCE Advanced Level Chemistry Practical Series, experiment number 12, showing the presence of nitrogen in air by an experiment. In this experiment, we aim to show the reaction between magnesium and atmospheric nitrogen and the formation of magnesium nitride. As you know, students, when magnesium is burnt in air, apart from magnesium forming magnesium oxide, it will also react with the nitrogen in the atmosphere to form magnesium nitride. So the main aim of this particular experiment is to show the presence of nitrogen in air by reacting magnesium with nitrogen under special conditions and observe the presence of magnesium nitride that is formed. Now, let's move on to the equipment and the chemicals we will be using for this experiment. Now, let's take a look at the chemicals and the equipment we'll be using for this experiment. For this experiment, we will be using Nessler reagent. We'll be using a small beaker along with a small dropper. We'll be using magnesium ribbons or magnesium strips. So over here we have a small piece of magnesium that is freshly cleaned. And then we have red litmus paper. And we are going to be using a pair of tongues, a spirit burner, a Bunsen burner, a crucible with a lid, and a clay triangle to hold the crucible in place while we heat the crucible. Now students, as I mentioned earlier, we are trying to show that the atmospheric air contains nitrogen. Around 78% of the atmospheric air is actually nitrogen. Around 21% will be oxygen, and there's going to be another 1% of other gases, inert gases, and carbon dioxide. So in this experiment, we are going to show that nitrogen is present in the atmosphere by taking magnesium, which is a group 2 element. As you know, when group 2 elements are heated in air, they are capable of forming their oxides alongside their nitrides. So if you take magnesium and heat it in the presence of oxygen or in the presence of atmospheric air, you are going to be producing magnesium oxide and magnesium nitride. So to make sure that this magnesium comes into contact with enough nitrogen and not only oxygen, we are going to conduct this experiment in a small crucible. So we will be having a piece of magnesium here. Ideally, you will be heating the crucible while the magnesium pieces are inside the crucible. And as you know, there will be a limited amount of oxygen. And as it runs out, the nitrogen will have a better chance of reacting with magnesium, producing magnesium nitride. Now, in our experiment, we will light this piece of magnesium. We will heat it until it ignites, and we will introduce it into this crucible, and we will close the lid, and we will allow the magnesium to react with the remaining amount of oxygen in this crucible and then start reacting more with the nitrogen inside this crucible, eventually producing both magnesium oxide and magnesium nitride. So afterwards, if you take the white color residue that is formed and if you dissolve it in water or if you react it with water, you are going to observe the formation of ammonia. Magnesium nitride, when reacted with water, will form ammonia. Magnesium oxide will turn into magnesium hydroxide, which is not very soluble in water. So it will remain as a white color solid. However, the magnesium nitride will react with the water to produce ammonia, can be identified by the use of Nessel reagent. As you know, Nessel reagent, if you add Nessel reagent to a solution containing ammonia, that particular Nessel reagent will turn into a brown color. It will form a brown color precipitate in the presence of ammonia or ammonium ions. So since magnesium nitride reacts with water to produce ammonia, if you take that solution and if you add a drop or two of Nessel reagent, you are going to observe the brown color precipitate that is usually formed in the presence of ammonia. Apart from that, you can take a small portion of the white residue, dissolve it in water, and take a red litmus paper and observe how the solution that is formed is going to be alkaline. So therefore, the red litmus paper will turn blue when you take a small portion of the solution that is formed when magnesium nitride is reacted with water. You have ammonia formed at that point. So the ammonia solution, when tested with litmus paper, red litmus paper, it will turn to a blue color. Now, without further ado, let's move on and conduct this experiment. Since we know the steps of this experiment, you can expect different observations that we are supposed to be observing in each of these steps. First, let's turn on our Bunsen burner and we can start heating the crucible, and we will then, after the crucible is hot enough, we will then take the magnesium strip and we will heat it up and we will include it in the crucible to see the reaction. Now students, to speed up the reaction, we have started heating up our crucible and we have a spade burner here. We are going to be using that to burn our magnesium strip that we have here. So let's first, we can light our spade burner, and with the use of a pair of tongs, we can take this magnesium strip that we have over here, and now we are going to heat it up. As it lights up, students, we are going to be including it in this crucible and we are going to close the lid. And this reaction will continue to happen inside the crucible. Crucible is still being heated. We can turn off the spade burner here. And as the crucible is heated, while the magnesium piece is inside, two things will happen. Magnesium will react with oxygen to produce magnesium oxide, and with the nitrogen present inside this crucible, magnesium will react to produce magnesium nitride. So let's allow this reaction to happen for a while, and then after the magnesium piece has completely turned into a white color residue, we will take out the magnesium piece and we will observe what happens when we react this white color residue with water. Students, now we have allowed this reaction to continue for about half an hour. We have heated this crucible for half an hour. Let's take this crucible off of this tripod and observe the white color residue that is formed. When you are removing the crucible lid, please make sure to place it on something like a tile, because otherwise if you place it on a wooden table, it will start to burn because the crucible lid is going to be extremely hot. And students, as you can see, inside the crucible you can observe that the magnesium strips that we added are completely turned into a white color residue. If you observe here, it is completely a white color residue. Now you can remove these white color residue. It actually breaks apart when you try to hold them. You can remove this onto a petri dish. After removing this onto a petri dish, we can remove this crucible out of the way along with its lid, because these are still extremely hot. And then we can take this white color residue and continue our experiment with this white residue. Now students, to move forward with the test, we are going to be using a watch glass, and we are going to transfer a small amount of this white color magnesium oxide and magnesium nitride residue that you have here onto a watch glass. And you can observe here a white color residue. We are going to add Nessler's reagent to this residue. Now students, as I mentioned earlier, when you heat magnesium strips in a closed environment like the crucible that we used, after the oxygen in that environment runs out, it will start reacting with the nitrogen in that environment to form magnesium nitride. When you react magnesium nitride with water, ammonia will be formed. Now, ammonia can be identified by the use of Nessler's reagent. Over here, we have Nessler's reagent, and we are going to add this Nessler's reagent to our white color magnesium oxide and magnesium nitride residue. So let's take a small amount of Nessler's reagent. As you can see, Nessler's reagent is a clear solution. If you add this aqueous Nessler's reagent, now Nessler's reagent is an aqueous solution, so it contains water. So if you add Nessler's reagent directly to this magnesium oxide and magnesium nitride residue, magnesium nitride will dissolve easily in this water to produce ammonia. So therefore, Nessler's reagent will turn to a brown color precipitate. With ammonia, Nessler's reagent will form a brown color complex which is not very soluble. So it is going to be present as a brown color precipitate. So let's add a few drops of Nessler's reagent to observe if there is a color change. Now let's add a few drops of Nessler's reagent here. As you can see students, when you add Nessler reagent, you can see the formation of a brown color precipitate. You can see the formation of a brown color precipitate. Nessler reagent is a clear solution, but as you add Nessler reagent onto this magnesium nitride, magnesium oxide residue, due to magnesium nitride reacting with water, it forms ammonia and it turns this Nessler reagent into a brown color. Now students, as you can see, we can very clearly observe the brown color precipitate formed due to magnesium nitride reacting with water and releasing ammonia. And as ammonia comes into contact with the Nessler reagent, a brown color complex will be formed, which is water insoluble. So you can see the formation of a brown color precipitate. So this is an indication that atmospheric air had nitrogen in it. As magnesium reacted with the nitrogen, it formed magnesium nitride, and when we add aqueous Nessler reagent onto magnesium nitride, Magnesium nitride reacted with the water in aqueous Nessel reagent and released ammonia, and ammonia and Nessel reagent produces brown color precipitate. Now let's move on to testing the pH of this solution. For that, let's take a petri dish and let's add a small amount of our residue. And to this, we will add a small amount of water. Now, after adding water with the use of a stirring rod, we'll mix the residue and the water really well, and we can observe the pH of this solution that is formed with the use of a litmus paper. If the solution is alkaline or basic, this red litmus paper that we have with us, the red litmus paper we have with us should turn blue. As I mentioned earlier also, we have magnesium nitride and magnesium oxide. Of course, when you dissolve it in water, you're going to form magnesium hydroxide when magnesium oxide dissolves in water, but magnesium hydroxide is not very soluble in water. However, magnesium nitride, when it reacts with water, it will form ammonia, which will make the solution alkaline. So let's take this red litmus paper and let's dip it in this solution that we have formed. As you dip this red litmus paper in this solution, you can see the red litmus paper is starting to turn into a blue color. If you keep it in for a while, this blue color will be more prominent. So the solution has started to become basic. The reason for this, as I mentioned earlier, is the release of ammonia gas. Is the release of ammonia when magnesium nitride reacts with water. So students, we have our litmus paper here. Now you can see litmus paper has turned into a blue color. The litmus paper has turned into a blue color, indicating that the solution was in fact basic. With that, we can conclude this experiment. As a summary, we observed that magnesium, when it is burned in air with enough and more oxygen, it will form magnesium oxide and a little bit of magnesium nitride. However, when you heat it inside a crucible, magnesium oxide along with a substantial amount of magnesium nitride will be formed. And when magnesium nitride is reacted with water, or when magnesium nitride comes into contact with water, it will form ammonia. Presence of ammonia can be observed with the use of Nessler reagent. And we took a small sample of the white color residue and we added Nessler reagent. We added Nessler reagent to this white residue, and we observed that the Nessler reagent will turn into a brown color precipitate, or there will be formation of a brown color precipitate in the presence of the Nessler's reagent. So Nessler reagent will only produce a brown color precipitate if ammonia or ammonium ions are present in the medium. In this case, when we added aqueous Nessler's reagent, magnesium nitride dissolved in the aqueous Nessler's reagent or in the water present in the aqueous Nessler reagent and produced ammonia, which eventually led to forming a brown color precipitate. And later on, when we used a litmus paper to observe whether the litmus paper turns blue when magnesium nitride is reacted with water, we in fact observed that litmus paper turns blue in the presence of a solution that is made with magnesium nitride and water. Magnesium nitride, when reacted with water, released ammonia, made the solution alkaline, therefore turned red litmus paper into a blue color. So this proves that we have nitrogen in our atmospheric air. With that, students, we can now move on to questions and other important theory parts revolving around this practical.